Good morning. I see people are starting to come on in. If you guys can just comment or chat below so I know who's in here. Good morning, Rafi. How are you today? I'm perfectly good. Got my coffee, so I'm good. You guys don't normally see me drinking coffee because it's early in the morning, but I am here with my coffee, so I am good. Rafi, you have a great question. What lab should I do today? Here's where we stand because Rafa, your period was actually a period ahead of the period 5 because of just how the rotation schedule works. So you may have actually already done the work for today. If you go to Google Classroom in the assignments, you will see I posted a video of me lecturing parallel circuits and a blank worksheet number 3. Your goal today is because of everything going on again, is just to try your best to do the front part of worksheet 3 and take a picture and submit it in Google Classroom. That is all I am asking you guys to do today, Google Classroom. If you want to do more, you can. If you have a paper copy of worksheet 4, then you can finish it all. If you only have the digital copy I posted on Google Classroom today, there are going to be some blank pictures because obviously I drew them out by hand before I copied them. So your goal is to at least do the first page, and if you want to do more or if you can do more, do more. But once again, I only want you guys to submit today just the first page of worksheet 3. There's a tab in Google Classroom, an assignment. Just upload the picture, and we're going to go from there. Okay, Rafi? Good morning, Liz. How are you today? Okay. Good. Okay. So, Alyssa, I'm going to tell you the same thing I told Rafi just a moment ago. On Google Classroom, below the link for this stream, you're going to see a 9-minute video of me doing lecture 3 and a worksheet that goes with it. Today, all you got to do is do the front page of lecture 3 and submit a picture of it as proof that you did something today. So I'm here to help you guys out if you have any questions. I'll be on for the next half an hour or so. So if you guys have any questions about anything we've done so far or specifically parallel circuits, feel free to ask, and I'm here for you guys. Rafi, I don't have the note packet in front of me. What were the numbers for the resistors? Okay. Look at me. I even come prepared. I'm a good teacher. So, okay. So, Rafi, it looks like this, but the 10 and the 4 may be switched, correct? Okay. And are they just asking for the total resistance, or are there other questions too? All right, I'm going to go with the RT for now, and if there was another question, you can feel free to say something. The equation is 1 over RT equals 1 over R1 plus 1 over R2. By the way, I'm going to hold this up when I'm done so that you get a closer view, and you could always pause the stream. Okay. In this case, 1 over RT equals 1 over 4 plus 1 over 10. Just like this. Okay. Now, depending on your comfort with things, how you feel comfortable with things, I don't know. But you could do this 2 directions. You can either put this into decimals or you can keep it as fractions and find a common fraction here. So if I did this as decimals, 1 over RT equals 0.25 plus 0.10. So that method is using decimals. Alyssa, you don't even have to print out the first page. You can just do it on a piece of paper and take a picture of it. But yes, just the first page is what we're looking for. If you don't have access to a printer, you do not need to print it out. You can physically do it on loose leaf paper and take a picture of it. Okay. So Rafi, in this case, 1 over RT equals 0.35. Just like so. Nope, you only have to do the first page today. I would recommend you do more just for your own benefit, but in terms of me looking at stuff, you only have to do the first page. So there you go, Rafi. And then at that point, I would solve from here, and you would get the total is about 3 point something ohms. Something. I'm not exactly sure. It should be 3 point something. If you do it the method with keeping the fractions, you would have to find a common denominator. So in this case, a common denominator here would be 20. So 5 over 20 plus 2 over 20, you get 7 over 20. And then since this is 1 over RT and this is 7 over 20, to do the actual calculation, you have to flip it over. So RT would be 20 over 7, which is 714. I think it's like 2.9. Oh, and I realized this would be closer to 2.92. I just realized my math issue. But just about 2.9 would be the work for that. So there's the idea of if you have common fractions. And here's the idea if you use decimals. So I'm going to zoom out a little bit to let you copy that down. And once again, feel free to pause and go from there. But that's how you would find the resistance using that equation. 2 methods with it. Question number 1 on the note packet. Is that the one? Is that the one I just did, Kylie? Okay. Okay, worksheet 3. Good morning, by the way. All right, let's see this problem. All right. Well, the first thing it says, by the way, is draw the circuit if it's not drawn for you. This one does not have a drawn for you, so you guys have to draw it on your own. It says that there's a battery. So don't forget, a symbol for a battery is 2 T's opposite of each other. And there's a 3 ohm and 4 ohm light bulb that are parallel. So what that means is that there's one complete circuit with one light bulb, and there's another complete circuit with a second light bulb. And I'll put the numbers in. So this is 1.5 volts. This is 4 ohms. And this is 3 ohms, like so. What is the current in each branch? What is the total current? And what is the total resistance? So generally, Kylie, and anyone else listening, the question order helps you figure out what exactly you're going to do. So the first question asks, what is the current in each branch? So I'm going to do different colors so you could see this better. To clarify, when it comes to electricity, we leave out of the negative side, go around, and we're going to go up this first branch, and it'll come back to the battery, okay? The other one does the same idea. It comes out the negative side, but here it will go through the next battery, through the next light bulb, and then back down, okay? So you could see, and once again, I hope the colors are showing up okay. You could see that there's 2 different tracks that they could take. Through this light bulb, it's just the red branch. Through this light bulb, it's just the green branch. But by the batteries, the 2 branches are going to come together. So in this problem, we're going to figure out the red one first, then the green one, and then we're just going to add them together to find the total. So how exactly are you going to find this part? Well, you actually know how to do this already. You're going to do V equals IR. So in this case, the voltage will be 1.5. You're looking for the current, and the resistance is going to be 4. So if I pull out a calculator, and I probably should have pulled out a calculator sooner. I do not know how to type calculators on the computers. There it is. Sorry, I'm just getting a calculator pulled up. Shame on me for not having a calculator ready. 1.5 divided by 4. So in this case, the I is going to be 0.375 amps. So that's the current for the red guy. Okay, just this light bulb. Okay, so what is the current in each branch? I have this guy, Kylie, and anyone else listening. If you want to do the current in the next branch, there's one value you're going to change. Instead of the resistance being 4, you're going to make the resistance be 3. Okay, and you're going to get a different number. I'm not going to do the work for you guys because this is part of the things I'm looking at. I at least started you off, but you're going to have to do V equals IR one more time with 3 instead of 4. That will give you the current in the red branch and the blue branch. So when they ask for the next question, what is the total? Notice the two guys, you just add them together. So whatever numbers you get, you're just going to add them together. The last question on that problem, what is the total resistance? There's 2 ways that you can do that. The first method is use V equals IR one more time. How'd I get 0.375? I have my work here. The voltage is 1.5. The I is what we're looking for, and the R is 4. So I just get the I by itself, 1.5 divided by 4. That's how I get 0.375. Okay. And once again, you guys can always pause this and replay this as much as you need to help get it. Okay. For the last question, you can use V equals IR. The voltage will be 1.5. The I is going to be the total current. And this guy is your question mark. So for the last question, yep, you only have to do the first 2 problems. I recommend you try more, but in terms of submitting stuff for me to actually see, yes, just the first 2 problems, Liz. Okay, so you can either use this method, or if they're asking for total resistance, you can use the total resistance equation. You can use this blue one. So depending on who you are, some people find this blue one easier to do. Some people prefer the red method. That's up to you. But either way, you're going to get the same answer within reason, depending on when you round. So I'm going to hold this up for a second. You guys can pause it, the video, when you need to. But to find the total resistance, you're going to use one of these 2 methods for parallel circuits. Okay? Awesome. You guys are so awake for a Monday morning. I love it. Rafi, do you mean? Oh, that's what I have planned for you guys Wednesday, is to show you that last little bit that I missed in your class. So that's Wednesday's lesson, is to finish that part up. Rafi, obviously things are gonna slow down a little bit. I'm not really supposed to be teaching you guys new stuff, but we're trying because you guys are an honors class. So this is where we're gonna stand for today and tomorrow, Rafi. Wednesday we'll do this again with the other video about lecture 4 if we need to. Would it be 4 ohms for question 1? Is that what you're referring to, Alyssa? It should not be 4 ohms. I could tell you, because of the nature of this, if you have a 4 ohm and a 3 ohm, the answer should be less than 3 ohms. That's just how the math actually works. Which method are you trying to use? Are you doing the V equals IR with the total current, or are you doing the total resistance equation? Yeah, Kylie, you can. You can literally use the same equation for each part of the problem, except for total current. Total current, you would just add up your 2 currents in each branch. But Alyssa, yeah, which method? Okay. So all right. Did you follow how we got this answer for the current in the red branch? And Alyssa, I'm talking to you. Did you get this answer for that branch? Okay. Now, for the second branch, did you replace the 4 with a 3 and get a different number? Oh, there you go. That's why. Yeah, because remember, in this case, there's 2 light bulbs. So when you look at the total, you got to get that all together. No, it's not wrong, Kylie. 0.5 amps is the correct answer for that question. So, Kylie, there's 2 methods at this point. We can either use V equals IR again, the voltage being 1.5, the I being the total current, and then you could find the total resistance from there. Or you can use this equation from the lecture, which is the video is posted online. 1 over RT equals 1 over R1 and 1 over R2. So obviously here would be 3 and 4, and you would just have to do that. That sounds right, Lisa. I didn't actually do the math yet, but yes, that sounds like a very reasonable answer for what it should be. Okay. Kylie, I agree with you. Just don't forget the units. Power supply It's actually going to be the exact same picture, just with different numbers. Instead of here 1.5, it should be 120, and 45 and 60 instead of 3 and 4. So it's actually the same exact picture, just different numbers. So don't let the power supply versus battery scare you. Bye, Rafi. Have a good day. Kylie, which method are you using? V equals IR or the 1 over RT? Okay. So, Kylie, all you're going to do is the V is going to be the 1.5 we've been using, and the I is you're going to use the 0.875 you got from before, and the R is what you're looking for. Um, List, that sounds about right. I didn't do the math yet, but from what the numbers look like here, yes, 4.6 seems very reasonable. Yes. And you can look back in the chat to see what Liz got because she had a question about that too. So you could double check with what Liz got. Liz, that sounds right again. Yes. Yes, you do the exact same thing, just different numbers. Mhm. Kylie, look at the units. 120 is the voltage, and the 45 and the 60 is the resistance. The ohms is the giveaway about that. So be careful with the units. Bye, Liz. Have a good day. Yes, Kylie, I agree with you. Yes, that's correct. All right, guys. It's been about 40 minutes or so. I do have to help the CP kids out a little bit, so we're going to cut it here. Once again, for the time being, um, just worry about the first two problems on worksheet one. Take a picture of it, submit it into Google Classroom. Tomorrow, I will not be streaming. I will be giving you guys a PhET simulator, just like you did for the series lab. And you have to match up the pictures and then get some values. So you will see that there. Wednesday, I will do a longer stream for you guys. And I will post the schedule tonight for Wednesday. But once again, Tuesday, I will not be streaming. Wednesday, I will for you guys. So please keep an eye out for that. Good luck. And you could, of course, email me if you guys have any questions, okay? Other from that, have a good day. And thanks for coming out. I appreciate it.